Meow! Is the cat alive? Or is it dead? All right, gather round, folks. Let's talk about the most famous and probably most confused kitty in all of science. Schrödinger's cat. You know the one, is it alive? Or is it napping for all eternity? What's the deal? This whole thought experiment was cooked up by a super smart Austrian physicist named Erwin Schrödinger back in the day, 1935 to be precise. His goal? To show us just how utterly bonkers the teeny tiny quantum world is when you try to apply its rules to our everyday macro-sized lives. Spoiler alert, it gets weird. So what's the setup? Imagine we have a perfectly innocent cat. Meow! We place the cat in a sturdy box. Also in the box is a teensy bit of radioactive material. Now, in the next hour, there is a 50/50th chance that one of its atoms might decay, or it might not. It is like the universe's tiniest game of chance. Here is where it gets diabolical. We have also got a Geiger counter, a radiation detector hooked up to a little hammer, which is poised over a flask of, well, let's just call it instant naptime juice for cats. If an atom decays, the Geiger counter clicks, the hammer falls, the flask breaks, and you get the picture. Poor kitty. If no atom decays, nothing happens, and the cat gets to keep napping peacefully. Seems straightforward, right? Not so fast. Welcome to quantum mechanics. In the wacky world of the super small, particles do not like to make up their minds. That radioactive atom, according to quantum rules, until we look at it, it exists in a fuzzy superposition of both decayed and not decayed at the same time. It is having its cake and eating it too. And since the fate of the cat is tied directly to that indecisive atom, this implies that the cat itself is also in a superposition. It is both alive and dead simultaneously, a fuzzy, purring zombie cat of probability. But only for as long as the box is closed. The moment you peek inside, you force the universe to pick a card. The wave function collapses, and the cat is definitively 100% either alive or dead. No in between. I know, it sounds completely ridiculous, and you are right. Our brains are not wired for this. Schrödinger knew it was nonsense too. That was his whole point. He was basically saying, look how silly quantum physics sounds when you scale it up to a cat. The truth is, the rules for tiny particles do not work for big, warm, furry objects made of trillions of atoms. All those particles interfere with each other, cancelling out the weirdness before it can reach kitty-sized proportions. So rest assured, the cat in the box is definitely, certainly one thing or the other. It is not stuck in some quantum purgatory. So what was going through Schrödinger's dark mind when he thought up his cat torturing device? Well, that story begins in the 1920s, when physicists were staring into the atomic abyss, and the abyss was staring back with bizarre, confusing eyes. They knew the old rules. Isaac Newton's dependable laws of motion completely fell apart in this tiny realm. Particles like electrons did not behave like tiny billiard balls. They behaved like fuzzy clouds of probability, ghosts haunting multiple places at once. In 1925, Erwin Schrödinger went on a vacation to a Swiss chalet, and inspired by the work of others, emerged with something monumental, the Schrödinger Equation. Think of this equation as the ultimate recipe for reality at the smallest scales. If you give it a particle, an electron for instance, and describe its environment, is it trapped in an atom flying through space? The equation will tell you everything you can possibly know about it. But there is a catch. It does not give you a neat, tidy answer like the electron is here. Instead, it gives you a wave function, represented by the Greek letter psi. This wave function is the heart of our quantum magic show. It is not a physical wave like water or sound. It is a wave of information and probability. The wave function does not tell you where a particle is. Instead, it tells you the probability of finding it in any given place. The equation itself describes how this wave evolves over time, rippling and changing shape according to the forces acting on it. To find out where the electron is likely to be, you need to square this wave function. The result is a probability map, a blurry cloud where the peaks are the most likely locations for the electron. The electron is not in one place, it is everywhere in that cloud at once, a superposition of all possible positions. This was a staggering, beautiful, and deeply weird revelation. It worked perfectly for describing the behavior of tiny particles in the quantum realm, but its implications were so strange that they made even Schrödinger himself deeply uncomfortable. The equation said that nothing is definite until it is observed. The act of measurement itself forces this spread-out probability wave to collapse into a single definite point. The Schrödinger's cat paradox was never about actually putting a cat in a box. Please don't try this at home. It was a brilliant, funny way to start a huge conversation about what it really means to observe something and where the line is between the quantum weirdness and our normal reality. Even Einstein got in on the action. So what do you think? Is your mind sufficiently bent like mine is? Does the quantum universe seem as bizarre and fascinating to you as it does to me? Let me know your thoughts in the comments down below.
Thank you for watching. Hope you found this video informative and entertaining. Please subscribe, like, share, and comment. We do like to know and hear your feedback. And if you have the means, please consider supporting us on Patreon, where you can get early access to our videos and where we post bonus material. Till next time, this is Geeky Tidbits saying cheers and have a good day.